So explicit and recursive, you're going to be able to write equations recursively and explicitly, so we need to talk about what these are. We're going to do it arithmetically this unit. You'll do it geometrically next unit. So you're going to see this stuff come up again. There'll be different formulas in that situation though. Okay, so explicit versus recursive. An explicit rule gives a sub n, so that means a sub n, that's how you read this. A sub n, because it's a subscript, it's below. Submarines go below the water, subscript. Superscript, it's like Superman flying in the air, so that's why like exponents are superscripts, because they're high. So explicit rule says gives a sub n as a function of the term's position number n. So we talked about how we usually start at 1, right? So it's the position in line. So like typically in sequences we start at 1. In the sequence allows you to find any element of the sequence without knowing the element before it. Explicit formulas are very, very close. Very close to y equals mx plus b. So it's more similar to y equals mx plus b than the recursive. So y equals mx plus b is slope-intercept form, right? So the recursive rule gives the beginning terms, usually it's the beginning term, which is known as a sub 1. This is read a sub 1. Oops, I didn't mean a parenthesis there. Sorry, guys. A sub 1 of a sequence and tells how a sub n is related to one or more preceding terms. So a sub n is any term in the sequence. You can replace n. So you'll be able to replace n to figure out the terms in the sequence. This tells me how a sequence starts and tells me how to use the previous value to generate the next values in a sequence. So you can't find everything without the previous value. So this one you need the previous value to find the next value. So this is not as helpful when you're trying to figure out what position 100 is, because you would need to find all the way through position 99 to figure it out, because you need the previous value. So the explicit formula is better for finding any term, like especially the big ones. This is good for like the shorter terms. If you're just trying to find like the second or third, it's not that hard to quickly plug into this and get to it. So we're going to look at what these formulas actually look like now. So when you're ready, go ahead and flip to the next slide and we'll look at what the formulas actually look like. And we'll talk about how to use them. The next page you guys are getting to, this is the page you need to make sure you have out during your homework. Or at least write the formulas down at the top of your worksheet. Does that make sense? Otherwise, what's going to happen is you guys are going to make up your own formulas. Those are going to get stuck in your brain and you're going to think you're right. And then I'm going to have to try to undo what you guys just did. So use your notes. Like I said, these formulas will be given to you guys on your test. You do not have to have them memorized. Got it? So just practice using them. So examples. So explicit. A sub n equals 2n minus 1. So n is your current place in line. So if you remember from yesterday, we had our input-output. So n is your current place in line. So remember we had a table. So this is the n value they're talking about. N is like your x. And it is your place in line. So it's whatever term you're trying to find. So the arithmetic formula, so this is the important formula, so this is important, looks like this. So a sub n, you can replace n with whatever position you want to find. So this means replace n with any position, and that's the same n that's right here. So these two n's that are in the formula, if you replace that n with 2, that n also gets replaced. If you replace that n with 1,000,000, that other n gets replaced with 1,000,000. Then you have a sub 1, which is your first term. So it's position 1. Remember how we said we always start at 1 and not 0? This is what I'm talking about. You start with position 1. So that's a sub 1. And then from yesterday, hopefully you remember D is your common difference. So I think it's easier to look at this formula like this, so I would rewrite it like this and put the D in front of the parentheses, just because I think it's easier to have that D in front of the parentheses. So either way is fine, it doesn't matter, but that's kind of my thought process. Okay, so let's think about this for a second here. N is your position in line, right? Didn't we talk about that? So I told you guys we typically start at 1. If I do 1 minus 1, what do we get? 0, which means we only have an a sub 1 left over, right? So if you're doing position 1, what you're essentially doing is you're putting it into, the n minus 1 is there to move it back to 0, so it could look like slope-intercept form. So you see how it says n minus 1 in there? So we're starting at 1 with arithmetic. We usually start at 0 for a slope-intercept, so that n minus 1 actually gets us back to 0 if you were to actually use the formula, okay? So that's kind of what it's doing there, just so you're aware. We're going to keep it looking like this, so I'll show you examples of how to write it out, but that's just the first thing. So that's the explicit formula. Now let's look at the recursive. Again, you do not have to memorize these. I think that's very important you realize. Don't have a panic attack about trying to memorize them. So, a sub 1 is your first term. A sub n is your place in line. So this is just an example here. So this is an example. So we'll look at what it means. So this one is just an example too. Just so you're aware. So let's look at the actual formula. So a subscript is the place in line. The subscript in this case is your n value. So that's your place in line. And n minus 1 is the term before a sub 1. So it's your n. It's your previous term. So n minus 1 here means your previous term. Bless you. So in the recursive formula, you need the term before. So this is how it's written up. You tell what the first term is. So that's step 1. You have to tell everybody what the first term is. Then you get to write this formula. And then this is your place in line. And this is the previous term. N minus 1 means previous term, and then we know D is the common difference. Okay, so one last thing before we get into examples that I want to talk with you guys about is what things you're going to replace and what things are going to stay in the formula. So it's important that you understand that anything that has a box around it is the only thing you're replacing. So the only things that you will replace in these formulas are the things with boxes around them. So you'll put a number here, and you'll replace this. So the only thing you'll replace are the things with boxes in them. Everything else will remain in the formula. So everything else is going to remain in the formula. Everything else will stay in that formula. So we will never replace a sub n. A sub n will stay there, just like we never replace y, right? In y equals mx plus b. A sub 1 gets replaced with the first term. N will never be replaced. Kind of like your x value. Does your x value ever get replaced in y equals mx plus b? No. And D is going to be replaced with your common difference. So these two pieces will stay in there. It will remain looking like that. These will have numbers in them. In this formula here, where a sub 1 is, you will tell me what the first term is there. This a sub n does not get replaced. It's like your y. This is like, take back a step, that stays in here. A sub n minus 1 will always stay there. The only thing that gets replaced in that part of it is the common difference. So before I do examples, this is a lot of information. What questions do you guys have? Okay. So let's do some examples. So we're going to write the first 6 terms of the sequence and then graph it. So it tells you what your first term is. This is a recursive formula. So this one is recursive because it tells you what your first term is. So if you are told what your first term is, you have a recursive formula. Do you notice how this one does not tell you what a sub 1 is in number 2? So if it doesn't tell you what it is explicit. So that's the biggest way you can tell the difference between explicit and recursive is, does it give you that first term or not? So the recursive formula says you need to use the previous term to find the next term. So we have to find a sub 2 next. The first term is -6, and it tells us that our common difference is, what does it say the common difference is? 4. So this added on to the end is our common difference. So what would a sub 2 be then? How could I find a sub 2? Madison. Very good. So then we take our previous term, which is to get a sub 3. So previous to a sub 3 is a sub 2. So -2 plus 4 is what, Kaylin? 2. So you just keep taking your previous terms. So a sub 4 would be what, Vivian, then?
6.
Yeah, the previous term to 4 is 3, which is 2. 2 plus 4 is 6. Jenny? What would a sub 5 be? What's the previous term to a sub 5?
4.
But what is the number that goes with 4?
Just before 5.
4 is before 5, but what number is assigned to a sub 4? 6. And what is our common difference? So you just add those two together and you get, there, that's your next term. Okay, Alexis, what's the 6th term? So you take the previous term, so the previous term is 10, and you add, which is, yes, Sarah.
Do you know where to start? Like, do you start from -6?
You have to start from a sub 1 to get to a sub 2. So in recursive, you have to start from your previous term to get the next term. So if they gave you a sub 4, you might have to work backwards. We're not going to do that to you guys, but But to get a sub 5, you have to start at a sub 4 and add 4. Does that make sense?
Yeah, I was like reading it all into one thing instead of splitting it.
Yeah, there's a comma there. You talking about this here?
Yeah.
Yeah, that's a comma there. Okay, so then you would just plot your points. You always start at 1. So 1 is negative 6. 2 is negative 2. 3 is 2. 4 is 6. And 5 is 10. And that's all that will fit on there. And we never connect our points. A sub 1 is given to you. So you start at a sub 1 is given to negative 6. So you know each term you should add 4. So I just took negative 6 plus 4 to get there. Yep. Any other questions? Guys, make sure you're asking questions. Like I said, this is new and confusing. So, Madison.
Like, is it okay how like the 6 term doesn't fit on the graph?
Yes. Because we already have the numbers plotted, so you can't change the scaling. So in an explicit equation, you kind of have to think about it as a table. So n is 1, 2, 3, 4, 5, 6. So to find your output, your y value, you have to plug that in. Yes, Jenny?
Okay, I just feel but like why, or like how would you use this? Like how would you know to use this in like a group problem?
We'll specify that it's an arithmetic problem by giving you the equations. We're going to be pretty specific about when it's arithmetic for you.
So this is just like
The
this
reason,
isn't something you're gonna use anymore. You're just gonna.
here's the reason mostly why we do it, and this is going to sound terrible. The EOC has problems with arithmetic and geometric sequences, so you guys need to see it before you take your EOC. Of all the things you're going to learn, is this the most important thing? No, not at all. But when the EOC, has stuff on it, you guys need to know it before you see it on an EOC.
What is it even used for?
It's just, it's a sequences and series thing, which when you get into like higher maths, like pre-calc and calculus, they do sequences and series, so it kind of is an introduction to some of that kind of stuff. And so it just kind of depends on where you're going with your, your career. All right, so for this one, you're actually going to have to plug in the number. So like your first position is always 1, right? So we plug in 1. So 8 times 1 is 8 minus 1, 8, is 0. So that's a sub 1. And then I plug in 2. So explicit formulas are a lot easier to use. So 16 minus 8 is 8. Then you would do 8 times 3, because that's the next position in line. So 24 minus 8 is 16. Could you figure out the other ones without continuing your formula? Yeah, what are we doing each time? Adding by 8. So we add 8 each time. Oh, that's 40. Obviously, most of these will not fit on there. So just plot what you can fit. Remember, you start at 1. So do not start at the origin. It's 1, 0. Just plot what you can fit. That's not a huge deal. So before we move on to some more examples, what questions you guys have for me? Because we have to get into writing the actual equations next. So that's using the equations, so let's talk about how to write them ourselves. So on the top of your piece of paper, what I would like you guys to do is write the recursive and explicit formula. So we're going to write those together. So the recursive is a sub 1 equals, and then there's like a space, a sub n, which is the term you're on, and then you take the previous term and add your common difference. So that's the recursive. Remember, we only replace this position and this position. So if you want to box what you're replacing, that might help you out. The explicit is a sub n. You take the first term, you add the common difference times n minus 1. So again, the only things you're replacing in this one are what are boxed. So that gives us the formulas right there on that slide. These are the same formulas that were on that slide on the previous page, but now we don't have to flip back and forth, right? They're right there for us. So we're going to write the explicit and recursive rule for each thing. So we're going to start with the recursive for this one. So before we do that, we need a sub 1 for both of them and the common difference. So what is a sub 1? Iris, what is a sub 1 in this problem here? The very first term is negative 30. Very good. What is happening each time, Hannah? The difference, the common difference. You're adding 12, so your common difference is 12. So a sub 1 equals what? We're using our recursive formula. A sub 1 equals? So negative 30 goes there. Then we have the equation part of it. We do not replace a sub n or a sub n minus 1. They do not have boxes around them. So we keep it like that. What is my common difference? 12, so we just put plus 12. So look at that and see what questions you have for me. Yes, Jenny?
Why is the a equals a minus 1?
That's saying take your previous term. So if you're trying to find term 2, so if I'm trying to find term 2, take your previous term, which would be term 1, and add 12 to it. So to find term 2, you need the previous term. So the previous to term 2 is 1, so I'd need negative 30 plus 12 to get term 2. So n minus 1 is just telling you take the previous term and add 30 to it. Which is kind of what you guys do when you guys do a table, right? Sometimes when you're making a table of values, you just look at the previous term and add the slope each time. That's essentially what this is saying. It's saying take that previous term like you've done a lot of times in your math career over the past few years. You've taken the slope and you've just add it to get the next point, right?
Wait, then why does it say n minus 1?
Because that gets you to the previous term. So if I want the second term, a sub 2, 2 minus 1 is 1, it gives me the term previous to it. So if I want the fifth term, I need the term previous to it, which is the fourth term. 5 minus 1 is 4. So that gets you backwards 1. So if you plug it in, that gets you to whatever the previous term is. So if I want the fifth term, 5 minus 1 is 4. So that says take the fourth term and add 12. So that's why that's there. We will be using these more with word problems on Monday, so maybe that will help out a little bit. So the explicit formula. We don't replace a sub n. A sub 1, what is my first term? What's my first term? Negative 30. I'll circle my answer too, so you guys. Yeah, we're not in the next problem yet. We still haven't finished this one. What's my common difference? So we do plus 12, and then we do not change anything in the parentheses. So it's 12 times n minus 1. So that's all you have to have there. So that's writing the recursive and explicit formulas. Okay, so let's look at the next one. Let's first determine a sub 1 and the common difference. So, Carly, what is a sub 1 in the next problem there? Good. Avery, what is my common difference? Good. So in the recursive formula, we have to tell whoever you're talking about what the first term is. So Alex, a sub 1 equals? Perfect. And then we keep everything else the same except the common difference. So I keep a sub n minus 1, and then I have to do something with my common difference. What is my common difference? Jenny?
It's negative.
So you have to do minus 300 instead of adding 300. Good. Okay, what questions do you have there? Okay, tell me what the explicit, yeah, Alexa, sorry. Negative 300, you mean? That's a common difference. So if you do 500 minus 300, it's 200. 200 minus 300 is negative 100. Negative 100 minus 300 is negative 400. So you're just looking at the difference from those terms. Does that help you? That's what we did yesterday in class. We worked on finding the common difference a little bit. Write the explicit formula, Jacqueline, for me. Just tell me exactly how it would read. Very good. Once you guys can plug into the formulas, it's really not too terrible. It's going to be the using of it when we get to that point. Yes. On the EOC, they're on the formula sheet for the EOC, and they're on your test. So we don't make you guys memorize these. All right, so let's do the next one here. We're going to skip around a little bit. I'm going to do this one, and then I'm going to skip to the last slide, most likely. Can I see this one? So, what is A sub 1, Jill? What? At 1 month, how many feet is it? 2 feet. 2. So it gives you the 1, 2, 3, 4 already. So, Kaylin, what is my common difference in number 5? What is happening each time? It is going up 1.5. Very good. So you guys have your formulas above there. So you're going to use them. Katie, what would the recursive formula look like for this one?
A sub 1 equals 2.
Good, and then?
A sub n equals A sub n minus 1 plus 1.5.
Perfect. Sarah, what would the explicit formula look for this one? Very good. So all we're doing today is practicing writing the formulas. You're not really using the formulas as much as you are to write them, because that has to be a whole another lesson, so you guys understand where that's coming from. So let's look at the very last slide. Bless you. The other ones are just, figuring out how much are being added in the image and stuff. That's not too terrible. Let's do those last 2 examples, and then I'll get you guys your homework. Okay, so write the recursive and explicit rules. So you guys don't have this on the top of this page yet, so rewrite your recursive and explicit rules on this slide here. Remember, we only replace what is boxed. Again, this might be a good thing to write on the top of your homework sheet once you get it too. All right. Morgan, I'm going to read this problem to you. Actually, I'm going to ask other people. You're going to write the recursive when we get to it, though. So the first term of the sequence is 5, and each term of the sequence is 15 more than the preceding. So, Iris, what is my first term? What is A sub 1? And what happens with my common difference? What is my common difference, Iris? So D is 15. Very good. So Morgan, then, what is my recursive formula? Good. Alex, what is the explicit? Whoop, be careful. Explicit, not recursive.
Oh. A sub n equals 5
There you go. This is why I say just rewrite the formulas on top of everything so you don't have to keep flipping back and forth. Okay, the next one says the first term of the sequence is 16. Each term of the sequence is 6 less than the preceding term. Each one is 6 less than the preceding term. So my a sub 1 then, my a sub 1 is what, Olivia? And what's the common difference? Spencer, give me the recursive of this one.
A sub 1 equals 16.
Good.
D equals 6.
D is 6. We already have that. So you have to tell me the actual recursive formula. So plug into this. You just have a sub 1 equals 16 so far, Spencer. What about this part of it?
A sub n equals a sub n minus 1 plus 6
It's not plus 6,
minus.
it's 6 less, so it's minus 6 because it's a negative 6. And then finally, the last one there, the explicit of it is what, Hannah?
A n plus 16
Very good. Okay. What you talking about? All right. So let's